Chapter 3, Vectors and Motion in Two Dimensions. The chapter goal is to learn more about vectors and to use vectors as a tool to analyze motion in two dimensions. Section 3.1, Using Vectors. A vector is a quantity with both a size, called a magnitude, and a direction. For example, velocity is a vector because it is both the speed at which an object is traveling and the direction. Speed is not a vector. It is called a scalar because it is just the number associated with how fast you are traveling. And this number has nothing to do with direction. A car may be traveling on a straight stretch of road at 50 miles per hour in the direction northeast. These two pieces of information define the velocity of the car, the speed is 50 miles per hour, and the direction is northeast. Another way to look at velocity is to represent it as an arrow in the coordinate plane. A diagram is shown at right. The length of the arrow represents the magnitude of the vector. The arrow is a common way to represent a vector since it clearly shows the magnitude and direction. The arrow starts at the point called the initial point, or the tail of the vector, and ends at the terminal point, or head of the vector. It is common to use a letter indicating the quantity, in this case velocity, using an arrow above the letter. In the book, vectors are indicated by a boldface font. When writing vectors, we will use a small arrow over the letter to indicate it is a vector. The magnitude of a vector is represented by the letter without an arrow. In this case, the particle's speed, the magnitude of the velocity, vector v, is 5 meters per second. The magnitude of a vector is a scalar quantity and cannot be a negative number. The displacement vector is a straight line connection from the initial position to the final position, regardless of the actual path. Two vectors are equal if they have the same magnitude and direction. This is regardless of the individual starting points of the vectors. The vector c is the net displacement because it describes the net result of the hikers having first displacement a, then displacement b. The net displacement c is an initial displacement a plus a second displacement b. This is called vector addition. The sum of the two vectors is called the resultant vector, or the net vector. Vector addition is commutative. Vector c is vector a plus vector b, or vector c is vector b plus vector a. In New York City, it does not matter if you walk 5 blocks north, then 2 blocks east, or if you walk 2 blocks east, then 5 blocks north. You end up in the same location. However, this doesn't work in Boston. The figure shows the tip-to-tail rule of vector addition and the parallelogram rule of vector addition. The vector E can be moved around the page as long as the length and direction does not change. Move the tail of vector E to the head of vector D. The resultant vector, or the sum of the two vectors, is drawn from the tail of vector D to the head of vector E. In the parallelogram method, vectors E and D have a common origin. Their tails are drawn from the same point. Draw two parallel lines to vectors E and D. The intersection is the head of the resultant vector, which has a tail at the common tail of the two vectors. Given vectors P and Q, what is P plus Q? The answer is A. Use either the head-to-tail method or the parallelogram method. Multiplying a vector by a positive scalar gives another vector of different magnitude, but pointing in the same direction. We have scaled the size of vector A by the scalar c. If we multiply a vector by 0, the product is a vector having 0 length. The vector is known as the zero vector, a 0 with an arrow above it. A vector cannot have a negative magnitude. If we multiply a vector by a negative number, we reverse its direction. Multiplying a vector by -1 reverses its direction without changing its length or its magnitude. Which of the vectors in the second row shows A plus B? The answer is C. Use the head-to-tail method. To subtract two vectors, A minus B, first draw vector A. And since minus B is the opposite direction of B, place the tail of minus B at the tip of A. Draw an arrow from the tail of A to the tip of minus B. This is the vector A minus B, which is same as the vector A plus the vector minus B. Given vectors P and Q, what is P minus Q? The answer is D. Change the direction of vector Q, then use the head-to-tail method. Which of the vectors in the second row shows 2A minus B?